Today, we are going to do something very familiar to all of you. So that is mass moment of inertia. And then I hope to continue on kinetics equation of motion. More important that on avenue to learn, okay, if we go to avenue to learn, I'm going to use quite a bit of diagrams today. So if you go on to avenue to learn, I hope the diagrams are there. I'll be using diagrams from week 11 Thursday example and also week 11 Wednesday example. Okay, so if you were to go to those sites to look to get the diagrams, it will be really helpful later on. Okay. So the first thing we are going to talk about the mass moment of inertia. And I like to clarify this, that the mass moment of inertia is not equal to the second moment of area, or sometimes second moment of inertia. Okay. What is the difference if we were to look at units? One unit on the left-hand side, the mass moment of inertia is kilogram meter squared. And the units for the second moment of area is meter what? 4. Okay. But both of them happen to share the same symbol. If you look at mass moment of inertia, we call it I. And we look at second moment of area, we also call it what? I. Okay. They are not the same at all. Okay. Later on, we'll see the difference in formula. Okay. I'd like to refer you all to this diagram over here, which you can get from yesterday's lecture notes. Okay, we go to the last page. So whenever you see a diagram like this, okay, very important, again, the blue column or the blue surrounding rectify to us, this is a what? Rigid body, okay? And very important to mention this, G is known as the center of mass. Yeah, repeat again, G is the center of mass. If you have a structure that looks, for example, like this is just an arbitrary shape. And when G is specified over here, okay, the vertical force that's coming here, down here, this is where the mass is what? The mass is acting on. Are we clear? Okay. So G is a center of mass. So if this thing weighs 10 kilogram, where is 10 kilogram acting on? Is acting on where? Point G. Are we clear? Whenever we do our analysis. Okay. So for this case, the rigid body is free to rotate about the z-axis with a angular acceleration of alpha. Okay. So the formula that we want to use with relation to t, so t is equal to I alpha. Okay, where t correspond to torque. Okay, and I was told that you guys are learning torque now. Am I right? Those who are in 2P, and I Now torque over here is Newton meter. Okay, I is the what? Moment of inertia. Okay, so the moment of inertia over here also rectify the resistance of the body when subjected to angular, when subjected to angular acceleration. And alpha, as we all know, is the angular acceleration. So the units over here is radians per second squared. Over here is kilogram meter squared. Okay. Now what you see down here, right, in this diagram over here, the transformation passes through the center of gravity or center of mass, okay, G. Okay, so if I were to draw a transformation, this will be our X, and this will be a Y. Over there will be our Z. Okay. So you can see that we have written torque in this form. Okay. So this corresponds torque in a what? Dynamic or rotating response. Okay. And I believe you will also see that torque is also equal P multiplied by R. Yes or no? This is also the same torque. But this is for what? When torque equal P multiplied by R, this is due to what? Static what? Loading. Are we clear? Okay. Where P is the applied force, R correspond to the what? Radius. However, when our structure is rotating with and what? Angular acceleration, torque is equal to what? I alpha. Okay. When will a shaft actually break? You have a shaft rotating in angular velocity of omega. When will a shaft actually break? Let's do something practical. Anyone? Yes. Yeah, it's due to shear stress, but when will it break? When the shear stress exceeds its yield strength. But when will the shear stress exceed its yield strength? Okay, it is I will teach you this. Okay, I want you to visualize this. ETB building. Eugene is standing on the 6th floor. Okay, stock market crash. Eugene decided to jump. I love Donald Trump. When will Eugene die? So this is first floor, second floor, third floor, fifth floor, sixth floor. Will I die on the fifth floor when jumping down? Let's say I have a very strong heart. I won't die, right? Will I die on the fourth floor? No. When will I die? When I hit where? When I hit the ground floor. Why did I die? Why did I die? Yes. Impact. So what happened during impact? At impact, at ground floor, can my body keep on moving down? Can my body keep on moving down? No. My body cannot move anymore. Right? So, like what you said, I'm just out of impact. Now let's look at the shaft. When will the shaft break? Yes. Okay? Yeah. And how can you not move the shaft anymore? When all of a sudden you decide to what? Induce a deceleration. Or induce a what? Acceleration. Or all of a sudden you want to stop the shaft from rotating. So if you look at most of the time, when for the car, if you have a feeling that your car will break, how to prolong or the shaft will break, how to prolong the line. Make sure you drive at 60 kilometers per hour, not too fast and not too slow. Are we clear? Once you start accelerating, what will happen? You have what? I alpha coming in. We clear? Right? Once you start accelerating, right? Once you start accelerating, you have what? You have I alpha going on. However, when you decide to brake, what happens? Two components start coming in. One is because of the deceleration, and the other one is because of the restrict what? Motion. Okay. So whenever you see that, you know that there's something wrong with your shaft that's rotating, and you still have to go on, what do? Make sure that you are rotating at a what? You make sure what will happen. You let angular acceleration equal to what? 0. When angular acceleration equal to 0, does not mean that omega is equal to 0. Clear? Okay? Physics, interesting stuff. Okay? So we know that the shaft or the torque will be acting on the shaft when during what? Acceleration. So the acceleration, the torque is equal to what? I alpha. Or during what? Sudden what? Okay, sudden. Where is all of a sudden equal to 0, then the torque is equal to P times by what? R. To stop the shaft, you need a what? You need to brake, yes or no? The brake is your what? Applied force. Are we clear? Okay. So just a bit of perspective for you, okay? But always remember this, okay? When anything in motion, okay, when it's under constant what? Velocity, you don't get a lot of force applied. Okay, it's when you decide to what? Decelerate or go to 0. Okay. Now, the next thing that we're going to look at, I need you all to draw up this diagram. Okay, so this is with reference to the diagram over here. So when looking at this diagram, okay, G again is the center of gravity.